Given the point -4, 2, I want to convert this to polar. So -4, 2 is in the second quadrant. If I draw a right triangle, the base is going to be 4, the height is 2. In order to find the hypotenuse, I have to use the Pythagorean Theorem. That's 4 squared plus 2 squared equals c squared. 4 squared is 16, 2 squared is 4. Add those up to get 20, and so c will just be the square root of 20. So the hypotenuse is also the radius. Think of that as r. So r is going to be root 20. Now you want to find the angle. So here we have to be very, very careful, because right now, because we're in the second quadrant, the base is really -4. So if you were to do inverse tangent y over x, that would just be inverse tangent 2 over -4. That's a negative number, so that's inverse tangent of -1/2. If you do this, you end up getting an answer in the fourth quadrant, because inverse tangent is only the first and the second quadrant. So from -π/2 to π/2, your answer is going to fall in this range. So from -π/2 to π/2, but you do not include -π/2 or π/2. So we're going to get an answer in the fourth quadrant, so we don't want to do this. It doesn't make sense. Okay, so let's not use this approach. The other approach is to use inverse sine. So like inverse sine is opposite over hypotenuse, it's 2 over root 20. Now the only issue with this approach is this is positive, and our answer is going to be in the first quadrant, because inverse sine is from -π/2 to π/2. So your answer will fall in this range. Because sine here is positive, it will be in the first quadrant. But keep in mind, our point here is in the second quadrant. So the way to go here is to use the cosine. And the reason is the inverse cosine picks values from 0 to pi. Okay, so let's see. We have cosine of theta is adjacent, which is -4, over hypotenuse. So apply the inverse cosine of both sides. And you see here the angle, or the length here, is going to be negative. So cosine is negative in the second quadrant. So we're going to get an answer in the second quadrant using this approach. And so we get 2.678 as our theta. And this, of course, is in radians. So r is going to be root 20. Theta is going to be 2.678. So writing it in coordinates, coordinate notation is root 20, comma 2.678. And that is our final answer.